Buoyancy and fluid mechanics. So we asked some students what they know about buoyancy.
Why we float in water is because we are mostly water, like 70% I think, and physics.
And they clearly had no idea what's it about.
Alright, I remembered something, guys. Okay, so when we were swimming, there was this really heavier girl, right? But she was like a great swimmer. We're like, why is she such a great swimmer? It was because, like, I guess fat floats, right?
Density of fat, or adipose, is smaller than the density of water. So what actually buoyancy is? Well, first, let's come back to the basics. In ancient Greece, a mathematician Archimedes came up with a law that any object submerged in a fluid will displace the amount of fluid equal to object's volume. From then, he concluded that we can calculate for the mass density of an object just by dividing its volume by its mass. And just having that, we can solve for so many complicated problems using the simple property of the mass density of an object over the mass density of the fluid being equal to the weight of an object over the weight of the displaced fluid. Now back to buoyancy. Imagine you have two objects, or in this case divers, submerged in a body of fluid. One of them is not moving at all, while the second one is floating on top. There are two forces acting upon each diver, the buoyant force and the gravity pulling him down. The first diver, which remains constant, is said to be neutrally buoyant as the forces are equal and of an opposite magnitude. The second diver is floating on top. That's because the forces are not of an equal magnitude and the buoyant force is overcoming the force of gravity. Now, how can a diver control his buoyancy? Everything is done by changing his mass density. With the use of air from his oxygen tank, he can change his volume, leaving the mass relatively constant. Doing that will make his mass density smaller, allowing him to increase the force of buoyancy acting upon him. That way, a diver can ascend or descend at will. We attempted to illustrate this phenomena in a swimming pool.
Mikolai and I are trying to visualize Archimedes' law in action. So, in doing so, we have a water bottle and we're going to put it at the bottom of his pool at a fixed depth, and we're going to see how it accelerates upward.
First, we set up measuring tape in the bottom of a 2-meter pool. And yes, speedos were an essential part of an experiment. To simulate an object with varying densities, we used a water bottle. We began with a bottle almost completely filled with water. We can control the mass density by changing the amount of air in it. That's why for the second try, the bottle was only 3/4 full. For the third try, it was only halfway full. The second trial is on the right, while the third one is on the left. You can see that the bottle with smaller mass accelerates faster. The last, fourth and fifth trial were performed using a bottle only 1/4 full and an empty one. The shape or the volume will remain relatively constant as we are working on a very small depth. The conclusions from the experiment agreed with our hypothesis. So yeah, things float, deal with it.